The, we have the bottle secured,
Okay.
and not that it's about welding, but we made a full wrap around here since we're using a strap for the securing. That's something you do a lot of times with round stuff when you're tying it down in your truck. Come over the top, make a full round, it keeps it from rolling, where if we just pushed it in, it could easily try and move more, making a wrap around it more secure. We'll turn the bottle on. And to set your gas, you actually need to have the torch on so that it's flowing gas, which we've already set that before. I set that at 15. Now this is a number 6 tip. Number 6 cup. The cup is a number 6. And that is 6/16 or 3/8 of an inch. And that should be running approximately 2 to 2.5 times the tip size in how many cubic foot per hour you're running. So it should be 12 to 18, and I put it at about 15. When you're using a flow meter, you also want to make sure that you're reading the correct scale. Like this one here is for argon, this one's for carbon dioxide. They are different. You want the numbers on the side that you're working. And that's standard cubic foot per minute, which is the cubic foot of the gas when it's out here at atmospheric 14.7, 68 degrees, and all the other wonderful stuff that the world has. So.
Is this what I'm going to be using here?
Yep. That's
How do you just turn it on by what?
it's
It's on weld right now. Does that mean it's ready to go?
Yeah.
Okay.
Yeah, I've got it set for 11. And you can see what you like. We'll turn the welder on. We have the control comes up here.
Oops.
Of course, each welder is different, but since part of this is video about explaining this particular welder, and if you hit that, don't hit the foot pedal, but if you did hit the foot pedal, it will be ready to start welding in a little bit.
Yeah.
It's gonna come on. We're set for DC TIG right now because we're working with steel. When you're welding with steel, aluminum, anything you weld, it really pays off to have it clean, and that's why I ground this off. Even though you can weld scale, you can weld with rust on it, aluminum has to be clean for aluminum, or it causes you problems. While I say that, I have welded some dirty aluminum, and a lot of people have too. You can boil it out a little bit and do things, and then grind off the after it's ugly. You're not gonna just weld dirty aluminum to something else, but sometimes you've got on a casting or such where you let it boil out a little bit and then you grind it off and you still have to clean it. It's just that you might make an initial arc on some dirty aluminum sometimes to let it clean out. But clean is the best, and clean is key. Part of the thing with clean, if we look at the torch here, Bob, we've got all up in here, while we flow inert gas out of this, there's still, when you're heating up whatever you heat up, there's the particles of that metal that's going all over the place that you can't see. And so you can contaminate your tungsten. We're doing DC right now. We're running DC straight polarity. And yeah, it's
Looks like the tip is just a little bit burned right now even.
It is a little bit. I was running it a little bit hot. And you will get some misshapening on the end. Where it's really a problem and is where it starts having a lot of little craters. In fact, we can go. We'll just go ahead and grind it anyway. It was working sharper, nicer at first, and we'll just go ahead and regrind the end of this a little bit.
So you like to have that a nice sharp point as much as you can, is that right?
Yeah, the end is going to be not sharp after a while. It will.
And on different metals, do you require sharp or not as sharp or rounded or?
For aluminum, and we'll use a different electrode and go to do some aluminum a little bit later. For aluminum, in the old days, what we used to do is ball the electrode. It always was just plain balled. And what they do now, which I have not done that much of it with a sharp, is they run them to a point and a little bit of a flat on the end. So it makes a little bit of a ball on the end instead of the big ball.
Oh.
What we used to do is we would actually have the ball would be bigger. You'd reverse your polarity temporarily, so you're running reverse polarity, and that would melt the end of your tungsten and make a ball actually larger than your tungsten. And when you were running a lot of amperage, you would end up with that ball actually almost being molten sometimes, even though you're welding with it. And if you pushed a little bit more on your amperage on your pedal, then
Yeah,
the
it would,
ball
huh?
would go into what you're working on and be a mess. And you used pure tungsten so that if it is boiling off anything, it wasn't going into your aluminum and contaminating it. Nowadays, they have several different ones, and I just bought some of what they call E3, which is a combination of different additives.
Thoriated or whatever?
Well, this is thoriated
Oh,
here.
that is,
This
okay.
is actually thoriated. And thoriated,
Radioactive.
slightly, yeah. And the thoriated is the most most stable at high temperature as far as maintaining its shape and not going away. And so that's usually, since you can use it on steel without the contamination being a problem, that's generally one of the preferred ones for steel. They claim that this E3 that we'll put in here later is supposed to be okay for steel and be able to use it for everything. Some people say that the lanthanated you can use for anything. Some people say the serrated. Zirconiated is another one, but they say it's better on aluminum and not really the best choice for steel. Some people say otherwise, though. Lots of different discussions on it. Old school, it used to be just two things, thoriated and pure. And the problem with the pure is, for the same size, it won't take as much amperage. So we were always using really big tungstens, too, when we were doing aluminum. Now, part of it, with the aluminum, you're running AC. But let's just weld a little with the DC before we start talking too much
Go ahead and
about
sharpen
aluminum.
that thing up. Let's
Yeah,
try it.
Yep.
And how far does that tungsten need to be sticking out or where in position to the end of the cup?
You can go up to the diameter, up to 3/8 of an inch out.
Oh,
So if it was a...
you mean the diameter of the cup?
Yeah, the
Yeah, I
diameter
see.
of the opening of the cup.
Yeah,
That's
huh.
generally what you can do. Now there's, and that's actually where it is 3/8. It's nice to have it out further. When I first learned, they always told me just keep it back as far as you can.
Okay.
Keeping it back further means that you have more it's more in the flow of the shielding gas. So it's more protected is why they
Yeah.
do that. At the same time, though, as you come around here and you get to your part, you don't have as much area in here to work. If it's close up to the cup, you're way down here when you're welding instead of up a little bit.
Yeah.
So you don't have the area.
So you
There's
got more room to fool around with.
more that you
Yeah,
can see
that's
and
right.
maneuver. Now, another thing that you find, and we'll start out with this. We're going to turn this over so you get not where I had welded already. New piece to play with a little
No,
bit.
I'm not experienced with TIG. I tried it once years ago.
Oh.
But when you do it, do you do it like welding? Sometimes you push into the weld and sometimes you go backwards. I think like gas welding, right? You just kind of...
Well, this is, yeah, a lot like gas welding, but one thing that's way different. And you've done much gas welding?
A little gas welding, yeah.
Okay, that is a bad thing, actually, for learning TIG.
Is that, well, not enough, so maybe it'll be good that I didn't do a lot.
because I do both, and I have trouble with it. I honestly do. Is that when I go back and forth, it causes me problem. And I've been doing a lot of gas welding and not much TIG welding
Yeah.
in the last few years. So the problem is when you're gas welding, you know how you move away from your puddle and the puddle gets bigger? You never want to do that with TIG. You want to keep a nice, consistent, about an 1/8 of an inch to 3/16 over the surface.
Okay.
You want to keep that same distance. And you change your puddle size by changing your amperage with your foot pedal.
Gotcha.
or by setting your machine if you just
Oh.
were setting a single size of amperage. And you'll
Okay.
do that sometimes, like if we were using this one here without an amperage control, we just set the amperage on the panel, it goes to that amperage, and that's what you get.
Yeah. So you got to
Now-
be mindful of, your foot and,
And what you're doing,
keeping
yeah.
track of that
Yeah,
part,
and see, my problem is, I know the foot, that's instinctive, because
Mm-hmm.
I've ran enough TIG, but I forget and I pull away, the same as on oxyacetylene. So I start making my arc too long because I'm instinctively doing both, and both is not correct. If I'm really doing a lot of TIG, I get back into it where, okay, this stays steady for distance and it's only the foot pedal. But I get to doing both because on the oxyacetylene, you pull away for a bigger puddle and you go in for a tighter puddle.
Well, I've seen some guys do some beautiful TIG welds, and of course, there's a lot of examples on films people have made.
Now, something that happens too with your flow, I shut the furnace down a little bit ago. I wasn't having problems here, but I still shut the furnace down to make sure that we're not having a problem. You always want to look around you and
for
see
shielding.
if you have an open
I
door or
see, yeah.
something. You know, the idea is that we have shielding gas that's coming out of here, and we have shield for our arc, but we also want to have shield for our metal around it.
Yeah.
And if you have an air flowing sideways, you can even blow your
Yeah.
shield away from where you're at. Now, some people go to the upper end of your flow with your argon. And that's a 150 cubic foot bottle there. So at 15 cubic foot, we have 10 hours that we can operate on that bottle. Which means that for what we just paid for this, it's going to cost us about $12 an hour for our gas.
Sure, constant welding.
Yeah, everything costs money. The other thing with that is if you turn it up, that doesn't fix everything. You turn up your gas, you've got more gas flow, but you're also making a venturi next to this. It'll start as you get faster velocity, while you can have a little more and it rolls up, it will actually still, because there's regular air here, it can start making a little bit of a venturi effect near it, and it
I
will
see.
suck air in.
Yeah.
So faster, higher flow is not always the answer for more coverage.
That's interesting.
They make bigger cups, they make diffuser cups. I've got some stuff for the other TIG over there. Some of it may fit. I've got different adapters and things, but I didn't mess with it. I'm just doing what came with this unit, just a straight cup at this point. And a bigger cup is going to give us more coverage and also more area around your tungsten. You can effectively, if you use a big tungsten with a small cup, you're clogging off your gas too, because you don't actually have the flow area. Now, if you're at an angle, you get more of that. You're blowing this way, you can suck air. You really want to try and stay relatively straight up. Now,
So, but how do guys hold the torch? Kind of like they're holding what?
whatever is comfortable for them. And then you can rest your arm on something, especially starting out. Give yourself a rest, an arm rest.
Yeah, right. In that
Don't
case-
try and just hold it out there with your
Yeah,
whole
yeah.
arm is tougher.
Yeah.
And now we got to get really buff to be able to do
Well, in
the
that
job.
case, the guy does need a lower stool because kind of like this. Well, you can do that.
Okay.
Weld out on the end
And
here.
we're just going to, what I want you to do here at first, Bob, you
gonna
need to
move
be
this
so
over.
that you can hit the pedal there.
Yeah, let me just
And
turn
I'll
this a
turn
little
this
bit.
off temporarily so you can get positioned with the pedal where it works for you.
Okay, so the pedal won't actuate since the machine is off.
Right.
Totally solenoid in there.
And so at the
What
top of
about spatter? You think my knee's in the way? Am I going to get, what kind of effects do we get from welding for any sparks or spatter or anything like that?
Almost nothing.
Almost nothing.
Yeah, almost nothing.
Okay.
You just get heat. If this was a scratched start TIG, you would actually come down, make your tungsten touch the part just a little bit,
Yeah.
and then you make an arc.
Yeah.
And that generally damages the tungsten a
Yeah.
little bit, but it's minor.
Yeah, I've got a XMT Miller welder that it says it has, it's an inverter welder, it says it has scratch start capabilities.
But it's also got high frequency, doesn't it?
No,
Or you
no,
have,
it's only for steel.
don't you have another TIG welder?
Well, I got that, no, yeah, right,
that's-
I do
that's
it,
what the
yeah,
one I was thinking
that's
of,
the
was
one that
your-
has high frequency. I'm talking
Yeah,
about my
yeah.
inverter welder.
Right.
And
right.
the one, the inverter welder I have to do scratch start on.
Right, which you can do scratch start, you can use a regular stick welder and TIG weld with it,
Yeah,
actually. You can actually set that up, you can get the torches with a valve on them. For DC, you can just use a regular stick welder. There's nothing special about the welder. They advertise ones that are meant for TIG, and sometimes they've got a valve in them for the gas, or they've got, all kinds of different add-ons. But until you really have the high frequency and AC, honestly, I don't consider it a TIG welder.
So what am I gonna do here? Am I gonna just make a little bead with filler metal, or am I
You're
gonna?
gonna just make beads without filler metal. You're
Oh.
just gonna get used to just melting. We're just starting out here.
Is that what you were doing on the other side?
Yeah,
Okay.
that was just melting the metal. And if you push the pedal down more, it will make a bigger
Oh.
bead. Now, what you want to really make sure you don't do is don't ever touch the tungsten to the part.
Okay, I understand.
And
Yep.
you don't want to come up a long ways either. This works very good. The high frequency on this, I was impressed. I could start up higher than I should be, and
Almost need to be up here like this, where you can really kind of see what you're doing.
higher would, probably be better.
Yeah, I mean the bench, if the bench was way up here.
Yeah.
Yeah,
Yeah,
see,
actually, the thing over there is normally I'll have a shorter stool, and that is a little bit taller.
Yeah. So it might be a
That's our
little.
normal TIG bench, but we just put everything here. The idea of this machine for our shop is a smaller machine we can take out and do little
Yeah,
jobs
I
somewhere
see.
if we
Huh.
want to, rather than having the big one that takes the 480, and this is more the portable concept. So yeah, we'll let you, you need
Oh, and my gloves, sure.
Yes, right there, 'cause
Yep.
you don't want to burn your hands.
So,
So yeah, so we'll turn it on. And are you going to be okay, Bert? Yep.
so I'm gonna come up here close and just what?
Just leave a gap, and you turn on, push the pedal down, and you'll hear it click, and it'll start flowing gas. And wait a little bit, and it will give, and then your arc starts. Now you can give it more pedal so that it will make a puddle. Yeah, there you go. And you just run your puddle around as you go forward.
And then I heard that when you're done, you actually, what do you do? You're supposed to stop for a minute and let the gas.
You let the gas keep going on the part so that the gas covers your weld as it cools down. So it's protecting it yet.
Pretty nice. I mean, I don't know how good I'm doing. I'll see after this is all done, but it sure is smooth.
You're running ahead a little bit quick, but it's okay.
Did I stop right?
Yeah, that's fine.
So what did I do here?
You just melted some metal.
Oh, I see. Well, it's kind of a straight line.
Yeah, it's.
So when I stopped, I shouldn't have had a dip. How would I avoid that?
Well, I don't think you really could, since we're just
I see there's a
melting
little-
what's here.
A little bit of pitting there. What is that from?
That's from being too far away or going too fast.
Okay. Yeah, but I had
you were
some pretty good
Letting it
fusion there.
oxidize instead of.
Should I try another one, or what?
Yeah, run some more.
Okay.
You may have also, I didn't really see, you may have been going a little bit too high of amperage possibly too.
Yeah, okay. I think a guy really needs to have it up high so you can really see what you're doing, or else be kneeling down or something. To be kind of leaning over the work and looking at it. It's not, but I can see it kind of. Let me try here again. What did I do? I stuck it on there. Sorry about that.
Now what's really different when we get to aluminum, and that's part of where I wanted to start with steel, it's harder to see the melting of the puddle.
Oh, I see.
Aluminum has a very small range between it's solid and all of a sudden it's so liquid that it just falls apart.
Can you see that bird?
Just barely, yeah.
And I can see you're running 88 amps right now.
Is that good?
It's probably
big it up?
fine. I mean, you can run more and make a bigger puddle.
How about now?
108. Unfortunately, a lot of these machines you can run the pedal and see where the amperage would go to. This one only reads the actual amperage you're using when you're welding. It will give me the setting, like now it's a maximum of 200, which is the most this machine will do.
I guess that
And
isn't too
you
bad,
went
huh?
slower, you didn't get the oxidation,
Oh,
and
yeah.
you let the metal flow in instead of jerking ahead of it.
I got a little bit better in just a short couple of
it
beads.
doesn't take a lot. It doesn't take a lot.
Neato.
What's tough here is, well, aluminum is tough,
Yeah.
generally. The other thing that's tough, and like on stainless, you have to watch for other oxygen around it will burn up and degrade the stainless so it looks more like mild steel. When your stainless is welded and it looks like mild steel, it's no longer stainless.
Oh.
It's messed up. Sometimes it's not as terrible, if you get a little bit of it, you could just grind it off but
I didn't
you
seem to
shouldn't have any.
hurt the tip too bad when I touched. It's still fairly pointy, so I made a mistake there and touched the work at first. But
Yeah, what it will do is the steel will actually go on top of the tungsten.
oh, you mean from the metal here?
Yeah, and
Yep.
that's where it's really bad.
Yeah.
Yeah.
And then does that stay on there then?
Yes.
Oh, it
yes,
just
it stays on there, and you've got to grind it off. Sometimes you have to break the tungsten and start over grinding it again. Yeah, I'll let you run another one, and then anyway, the other thing that is here is when you start getting your filler metal in here, the filler metal goes in the puddle you make, and remember that that's hot when you're here without a glove like me.
Yeah.
But the filler metal going into the puddle, you don't want to arc. You don't want to have your arc going to the filler, and you don't want to have, when you put the filler in, the bead gets a little bit higher. So sometimes, well, I don't think it's going to be a real problem here, but sometimes your bead will come up enough so you've got to temporarily move your back to maintain your proper arc because the puddle gets higher.
Yeah.
So as it comes up, this has actually got to go back a little bit as you're putting, but we'll see that.
Okay, so we'll do another one here, I
Yep.
guess. Try to maintain a little hotter one this time, maybe. See where I'm at.
Yeah, you're a little high there now.
Yeah, I can see it. Oops. Am I too far away from the work?
Yeah, it's straying a little bit. You see how it's going off to one side instead of coming straight
Yeah,
out?
hold on. I think the way I'm holding the thing, yeah, I wasn't
Well,
holding it.
that's the tungsten contaminated.
Oh, really?
Yeah.
So you want to take this out and grind it again?
No, I don't.
You don't?
But we do. We need to.
Are you
I
gonna-
don't want to, but we need to.
Okay, that was just from one touch, huh?
Yeah, that's all it
Wow.
takes.
Huh.
Yeah.
So let's see, pull that guy out.
Of course, the tungsten is hot.
Yep.
And yeah, put it out the end. I'm going to just go grab another piece of rod. Normally, you're doing this stuff, it's good to have a few tungstens already set up
Yeah,
nice
see.
and clean.
Yeah, you can see a little nib on there, but barely. So that's just some of that metal that we're welding got up on the tip, and it
Yeah.
just affects it terribly negative.
Yeah.
Huh.
Yeah, you saw where before it was coming straight out of the middle.
Yeah.
And then it's coming
Yeah.
off to one
Huh,
side.
that's interesting.
You'll do that if it's running too hot too.
Mm-hmm.
You're melting it off. But yeah, that's the steel on there. It's built up more than its extra material.
Mm-hmm.
Usually you'll get it and it'll coat all the way back. It gets a little bit worse. You didn't get a lot of steel on here, but usually when I do it, I dump it in. I mean,
Yeah.
I'm doing fine, and then I
Yep.
just get the filler rod, I pound, and you'll see it'll coat over all of it, and it'll actually make a ridge around the back here where it's just on the whole thing, and it's just, yeah, it's garbage. I guess
Yeah.
it's cooled enough. I'll go ahead and grind this same one.
Okay, so I'm going to put that in.
Yep.
So I guess we got to put this little collet on. And does this little rim go backwards or forward?
Yeah, that goes towards the point, the small part. No, you got it right.
Oh, I do have it right.
Yep.
Okay.
It goes in the
Sorry.
back. to
To
push it
come up
in.
against there, yep. Okay.
There's a collet body that's in there that goes against,
All right.
that we put in earlier before you got here. I put it in last night.
And we can
No,
adjust it out first,
Yep,
then we
yep.
can always push it back in a little bit if we need
right,
to.
right. Yeah, exactly. Start out long and then before you tighten it, push it
Okay.
in to where you want it.
It's a good friction. Looks like about where you had it. Doesn't take too much to tighten it up and it's good. See, I can see real good now. You notice I went down in the bucket
Yeah,
here?
no, that's good.
So I gotta move the pedal just a little further away. I think I'm gonna probably do super good now. Watch this. Is the machine on?
It's
Yeah.
on.
Okay, so. I did it again, I touched. Maybe I didn't have the pedal activated enough.
There's a delay. There's a 2-second delay to let the argon get there first.
Yeah, you're right. Well, it definitely helps to be right down there to be able to see what you're doing. Well, it's actually kind of a neat experience. I'm getting a little bit too much what?
I think you dipped in the puddle there at the
I think I
end.
did. I'm going to give John a job again of, but look at that, how nice that is. See? Up to that point.
Yeah.
I don't see anything on the tip,
Okay, we'll say you didn't.
but maybe I was pulling too far away.
Yeah, it might have been just air getting in there. I am going to.
You're going to let me fill now, huh?
Yeah, yeah. Now, normally, and the idea with this is the people learning to do TIG weld at home, that there's people on YouTube, welding tips and tricks. There's another guy, but he was the first one I started watching that was good. There's a few others. I forget the other one. That a lot of these guys have TIG programs and stuff also that they put out. I am not an excellent TIG instructor. I've had some good TIG instructors. I was adequate at TIG in the past. I'm not adequate now because I'm way out of practice. I was even borderline, never good.
Well,
I was never really good at TIG.
I had a couple
I
of,
was okay. I did it as a job. I was the TIG man at FM&S the
Really?
first time I worked there. I
Yeah.
actually was the TIG man there.
FMNS for Fairbanks Machine and Steel.
Yeah,
Yeah.
no. And
Well,
that was part of why they could keep me on. They had too many machinists,
Uh-huh.
and they needed another welder that could do TIG.
Hmm.
So I actually became the person that was doing the TIG for the welding
Hmm.
shop along with being a machinist.
Huh. Well, I had a couple, little issues, whether it be starting or stopping or touching, but I got a pretty nice looking, I'm impressed
That in there looks real nice.
yeah.
So the point is, normally, what you would want to do is you'd want to consistently have beads that look like that all the way with no problems
Yeah.
for probably a foot by 6 inches or something, where you've done a lot of them, so you've
Yeah.
had lots of practice. But we're going to move this up since we're doing, and you have your stuff at home you can practice with
Yeah,
too.
and this is kind of making me want to
go play with your own
play with my own
toys.
stuff, which I
Yeah.
haven't done because we haven't had anybody to really
Yeah,
kind of get
yeah,
me
I
going
told
on
you
it.
he'd come over, but this is better doing it here.
Yeah.
That's we get to help other people too. You have the argon, don't you?
I have argon, yeah, and the
Yeah.
machine, it's a big machine, it's got a cooler, so I don't know, there's just a lot of big stuff you got to deal with
The
there.
cooler is nice because for the same size torch, you get to run more amperage through the torch for a given size, and it stays cold.
So what do we have here for cooling?
Just, they call it air cooled, but it's actually argon cooled.
Oh, the gas
Because
itself is
the
cooling it,
gas
yeah,
itself is cooling it. There's a little ambient outside that's cooling things too, but the majority of it is the argon going through it. Now, with your water cooled, you have that also, but you have the additional, it doesn't cool everything. In the water cooled, there's water that comes up here, flows around this part of the holder. It doesn't flow through the collet, doesn't flow,
Just around it.
just
a little bit, yeah,
around it, just makes and helps take heat away. And I just bought a new one for the big TIG over there. I just bought a 500 amp handle.
Kind of making me want to
And
do something at home, you know.
so
Weld a bolt
here's
handle
your
together.
filler. Here's your filler. Now, you got to remember, you're going to want to get enough of a puddle so you're making a puddle and you're dipping the rod in over here.
Oh,
You got to have enough of a puddle so that,
understand.
and this is not touching or getting in between the
Yeah,
arc. You want to
okay.
be on the side of it, and the arc is on the puddle.
okay.
And what you'll find also is as you dip this in the puddle, you might get out of the puddle to where it cools off because this comes next to colder metal.
Yeah.
That's not really the puddle, and then it sticks.
Yeah.
So now you have to move your TIG over here to get back and get it free.
Melt it off,
And
yeah.
if you pull this way out after you dip some metal in, you'll be bringing the hot welding rod out of your shielding gas. So it will oxidize a little bit.
Oh.
So it's not going to kill you right away
Yeah.
doing that, but you get a little bit more
And that-
oxidation
when you put it back in,
than
it could
if you
start-
stay in the area where the gas
Oh,
is.
okay.
You know, obviously you're not staying right in the puddle. Now, there's another thing with this too is you see these aluminum welds all the time where they talk about stacking dimes and they have the
Yeah.
ridges all through it. That became a new fad about the same time that I was first learning TIG welding. And on steel, they don't normally even talk about welding dimes because it's a weaker weld. It's a weaker weld on aluminum too. But they do it for beauty.
Yeah.
So there's still a little argument, but most people, because it's such a thing that we do for, in quotes, beauty, I think it looks ugly to me, versus the older way you did it, which was you try to dip it to get as small of a bead as you can, as small and consistent, just like if you were doing stick, where you have this really even, pretty, you know, kind of like this is even laying in here, but you can see the distance between them. If you were dipping on each of those,
Yeah.
they would each be quite
Oh.
a large ridge. And we also, with this welder and with yours, we can set up different pulse functions so the amperage will automatically rise and fall and give you a time cycle that sets the size of your bead.
This sounds like a
But-
real test for the beginner guy.
Yeah, so I really, even though it can help a medium level welder do a better job having that pulse because it sets your size, it keeps it consistent, I don't think that it's a good idea to start learning because it's just too much. It's easier to use the pedal and to have your mind on what you're doing and decide what amperage you want. Anyway, now we'll give you some rod and just don't touch it to the tungsten,
Okay.
which is really easy to do when you're
Yeah.
starting out here.
Okay, let's see what you saw. What am I at for amperage?
You're at 137.
I think I was getting too far away.
You're at 110. And I'm not able to really get in there without messing with your rod because of where I'm at here. So I'm just letting you weld and not paying attention. Which, when I learned to weld, is what the instructor did basically too. They told us what to do, we did welding, and then they'd come back and look at it after we were done and say, yeah, you did this and that wrong, go try again, kid. I was
Well,
17 or 18, I don't remember when I first took
It's,
the TIG classes.
a little wavy, a little irregular.
But you didn't you didn't hit
I
the
did-
tungsten?
yeah, I didn't- I
No,
didn't.
that is great for a first time.
Not too
It
bad.
really
huh?
is.
Wow, neato.
Yeah. No, well, that's great.
So I need to try another one, is that right?
Go ahead, yeah, go ahead,
Okay.
play with it a little more. We can turn it over, let you weld on the other side. I could get another piece of steel if you want to.
I'll start over here. I didn't really do much over here yet.
Fan just came on in the welder. It's cooling itself. You're running about 80 amps now, Bob.
Okay. Yeah, I can tell I'm hardly putting it down.
Now part of it too is your piece is hot. So with a hot piece you don't need as much amperage to melt stuff either. Yeah, because the steel is hot.
Very hot.
I think I will cut another piece over here in the bandsaw real quick, and I'm curious, before we swap to other things, I'm going to turn this machine off, and I'm going to plug you into 110. As long as we're testing things. This welder runs on 110 or 220.
Oh.
It chooses, it selects what it needs to do if it, when you start out. And we're going to try it and see if there's any big difference for...
You mean with
how
a
it
cold
works for you.
piece, you mean?
Well, you'll have a difference because of being cold, but you also have a difference because your maximum amperage you can get now is 120.
Oh,
You
yeah.
weren't really using, but that's the maximum you
Oh.
can get because we're on 110 volt.
Let's see here. Ready any time, huh?
Yep. Wait for Bert to get there.
Okay.
You're ready. Yep. You having to go down further on the pedal to get the same amount of heat?
Yeah. And I don't think I'm even getting the same amount of heat. I got it all the way down now.
Yeah, it's maxed.
But I like the control there I have right now. Oop. I didn't touch it. Oops, I might have touched it.
Okay.
Oh, I got some pitting there. Don't show everybody my pitting.
Yeah. Well, you're getting too far away.
I don't know what I did, John.
You're probably raising up. If you didn't hit the tungsten,
What do you think of this tungsten tip? Is that... Might have just a little tiny bit on the end.
it's a little messed up, but
You should be able to still weld with it.
I don't know. It's messed up,
Really?
but it's not. Let's try it
keep
again.
trying it?
Go ahead
Okay.
and try it again. Go ahead and try
Let's
it
see
anyway.
here. All right.
It might be just that we're pushing it too much.
When
Well,
I-
no.
when I
we only got
started, I didn't-
120 amps. We're not pushing it too
Yeah,
much.
when I started, I didn't have the pedal all the way down, so I'm just going to start with the pedal. After I get the arc, go right to the maximum. Yeah, you really got to watch.
Yeah, you're trying to keep that consistent distance with the torch at the same time you're doing other stuff.
Yeah. Well, that one,
And
I didn't have pitting.
Yeah, you were probably just getting up too high.
Yeah,
Tungsten's okay.
yeah, that's
You
a
were
little
just-
better, isn't
You were
it?
just getting up too high, and so it was sucking, it was venturing,
Huh.
sucking air in. And you pulled away, you got some, at the end, you pulled your...
You're talking about right here?
Yeah, you pulled it away right away, so you got a little bit of a
You
problem.
mean I lifted?
Yeah, you lifted it
Oh.
right away instead of waiting for it to cool down.
Oh, okay. I should
So
have
it-
kept
so
this.
it- yeah, you should have held
Well,
it
now-
there, so it
now-
oxidized a little bit at the
So,
end.
okay, now when you stop with this welder, you
Release the
release the
pedal.
pedal all the way, but you stay in their
Yes,
position?
yes.
Because is there still a little gas that's
There's
flowing?
gas for another 3 seconds,
Oh.
4 seconds, yes.
You set it to 3? halfway.
Oh, okay, so there's a setting.
Yeah.
There's a setting how long the
Yeah.
gas
Yeah.
continues after the weld. Oh,
Yeah,
that's
usually I'm setting it at like 5 or 6 or whatever, but I was
Okay.
like, I had it set at 2. I gave it a
Oh,
little
okay,
bit
I
more.
would have held it
3
there
is,
a little longer, except I didn't know that.
yeah,
Huh.
yeah, you can actually, I can't hear it with this small cup. Usually I can hear the gas and hear when it shuts off.
I thought
Now
that
I'm
was
going to
pretty
try
good.
something else here too. While we're trying different things and checking stuff out, and I'm not familiar with the machine. Now it was on the 110, and it stopped us at 120 amps. I'm going to go plug us back to the 220, and I'm going to adjust it to a maximum 120 and see if it does the
Oh, I
same
see.
for you. Oh, that's interesting. It automatically came on our previous amperage. I would have had to turn it up to make it do more.
Oh,
It actually,
that
it
could
had
get-
automatically set itself down to the 110, but then when we restarted with 220, it has more available, but it's left it at the other setting.
Yeah.
So let's see if it welds the same as it did just a minute ago.
Okay, so it's all ready.
Yep.
Oops, hold on. Sorry about that, I was leaning on the ground clamp and all of a sudden it went moving. Let's try to do this a little bit. Keep that ground clamp away from me.
Yeah, what makes this nice, and a person should have, I don't even have over there on our TIG area, but a tree is nice. You have a tree that comes up, and you've got different little clamps and things, and you can position stuff and hold it up here.
Oh.
And especially learning, it's nice to be able to have, you position your part wherever you want to instead of just laying it on a bench.
Here we go.
Turn it upside down.
Oops. I hear a lot of sizzling there. I wonder if I touched it. I think I did.
I think you did.
Gave John a job again. I'm a little wiggly.
Did it weld better on the 220, even at the same setting? More consistent, or was it just pretty much equal, you think?
Well, you know, I don't know that I could really tell you that exactly. I know when we hit it on the 110 and I had the pedal all the way max,
Yeah.
that I liked, it seemed like it really had good control. And at this 220, I might need a couple more passes to get the feel of it. But it seems like it's a little different of a feel for me.
Huh, okay.
Yeah.
Because if you max it, it still is the same place as it was on the
Yeah,
one.
yeah.
At least according to the meter, it's the same on
I think
the-
I need to
what
try
it is.
another bead just to,
Okay,
I
but
have to look at the video, but the arc did look brighter.
with the 220, yeah.
Yeah.
Yeah, I was thinking it may be different, even though it, you set your amperage, and your amperage is the amperage when it's functioning, welding, but getting to that as it's initiating the arc, as it's doing things, it's different. It's not necessarily going to be the same. Sharper point, you of course can have a smaller bead and more accurate. Flatter point, you can put more amperage to it before it melts away.
oops. Probably should have put that little colic cup on there first.
Either way.
Don't grab it with your bare hands, right?
A lot of times you'll just leave, but I was having, you'll just leave the collet in the cup and pull it out the front.
What am I doing here? Squeezing it? Why is it having such a, there it is. That's just me with my gloves on.
Yeah, it's nice to do that barehanded, but then you got the heat of things.
Yes.
So it's also not nice. It's nice to set them all up when you're barehanded before you get going, and you only get to do that once when you start welding. It's also nice if you're doing this, and really, when you start out, get 1 or 2 tungstens that you want to play with types, and buy a full pack of it and grind them all for what you're doing, so you can just swap them out and keep going. You don't have to go running over to the grinder.
So I'm a little closer this time. I'm a 1/4 inch. Is that okay, or?
That's okay.
It is,
That's
okay.
okay. You just have to remember that what you're positioning is to the tungsten, not to the cup.
Yes. Okay, ready to go. Try it again.
Yeah, you'll have to do a comparison of the 110 and the 220 side by side, splice them in on part of the, there's a lot of editing. Somebody's going to be busy.
Be that guy.
Well, what did I do this time? I ran it all the way up, didn't I? Did you see what the
No.
meter was?
No, you were running about 100.
Okay, so it's kind of flat. I didn't put enough
You're
filler in,
coming
maybe?
away probably trying to make your puddle bigger.
Okay, let me try.
It's my guess.
I'm gonna try
You
one
were
more. One more.
doing
little
what
one.
I do. I go get into my oxyacetylene mode.
One more here. I'm having fun. Oops.
One of the things that's terrible you'll find out is where you've got those wormholes in there.
Yeah.
You cannot go back over that and melt it in and make it smooth. You have to grind that oxidized
I
metal
see.
out. It's with the TIG. Once you get those, you've got to get rid of them.
I see.
So if it was for a customer's job, you're running 71 amps, 80 right now, just for reference.
Yeah, I was kind of losing my foot pedal pressure.
Is that amperage working good for you now?
Seems like it.
Okay, we're going to do something else here in a minute. Do some more playing. And that's on a warm piece yet. So let's try something here, Bob.
Yeah.
We're playing with stuff. Let's take away your foot pedal.
Oh yeah.
We're going to take away your foot pedal.
Okay.
And we're going to put so that it'll initiate from that switch.
Oh, you mean this switch?
Yeah, so the switch will still set you as far as starting your gas and stopping your gas. But what it will do, you won't have amperage control. Let me get this plugged in first. So you'll just have the switch will start you, and let me set you for the same amperage you had.
So I start it up. Once it strikes the arc, it's going to go right to that.
It will take a second. It'll take a couple seconds to actually get to that amperage, but it will go to that amperage and just stay there. And this is actually, if you buy the machine without the foot pedal, this is what somebody would have.
Okay.
Because they sent us the foot pedal as a separate box.
It's ready?
Yep.
Oop, what did I do?
You have to hold the button down.
Yeah, it wasn't close enough.
Hold it continuously.
I am.
Okay, I'm going to have to readjust. Okay, try it now.
All right.
There's a selection on this for how it works with that switch. I think this is. Yeah, I had to go to the 2T position, second switch down. And on the 4T, from what I read in the manual, what it'll let you do is hit the switch once and release it, and it will let it start welding, and then you have to hit it and release it again when you come to where you want to stop. So you don't have to hold it down while you're welding. But I didn't want to get too confused on what we're trying to do while we're trying to learn stuff. The one I like is they make for on the torch, and it's really good for boat work, is they make one that has a slider. And it works the same as your foot pedal, but it's a sliding switch. And I like that real well myself.
Yeah, that wasn't bad. I kind of like that. Worked good.
And it's nice to have both. You know, ideally, which we've got the plug here. It's just a matter of wiring up the other style switch. And they also make ones that are a thumb lever that changes the amperage as you push it down. They make ones that are rotary dial. I don't really like that myself, the rotary dial. I couldn't quite get to where I could work it with the thumb or using it just never worked for me. I like the slider for changing the amperage on those, but it's nice to have one for field work. But you also saw what it was, you can just set the amperage and leave it. I mean, that's possible, and that's what I used to do for my old, and for another one I've got up there, I've got one in a suitcase that's a little 90 amp thermal arc, DC only. And this, we're only using DC now, but being able to do aluminum, do the AC. You want the, aluminum has an oxide on the outside of it. The aluminum oxide, which when you, what do you call that when we color the aluminum?
Anodizing.
Anodizing. When we anodize, the colored is different chemicals you add in, but when the anodizing makes that oxide thicker. You use electrically, you build up so it gets more of an oxide on there, and you color it sometimes. But you want to break through that so that you have liquid aluminum, because you don't want to be welding oxide. That needs to be on the surface, but not in the weld that you're putting in. So the AC, because it's moving, it stirs and breaks up that oxide on the surface and lets you get there.
Good explanation.
So,
What's next?
well, we could play a little more with this if you want to, or we can go on to working with AC.
Well, let's go on to AC now.
Yep, okay. So,
Now that I'm accomplished at TIG welding and steel, how does it compare to other units in, something that has the same capabilities in price? Like, what is the price range of other ones?
I don't know what they all are today, to be honest. I know that pretty much the ones that run 110, it's very hard to find any of them that do the AC.
Oh, really?
But there are some. And I don't know, since we're mentioning this welder, I don't know enough about the others. I'd be throwing people off by mentioning ones that I've heard of, or because I'm not looking right now. Now, what we're going to do too, because aluminum, we could have you just do a nice little weld there, but we're not gonna. And conduction's not going to be a lot of problem, but we should have it clamped. And I got to get your other tungsten set up for you too. But one of the things you want to do, and I better just clean these off, otherwise we're going to get oil on that stuff from these.
What is that, heat sink it?
What's that?
Talking about sinking the metal?
No, I want to get it up so that it's not on the table.
Oh, because
On the table, it's a little bit of a cheat and doesn't give you a good experience with playing with the aluminum.
are these 1, 2, 3 blocks?
Yes.
What are you doing with those here? You got enough of them, I guess. Huh?
We use them for all kinds of things. I'm going
Yeah,
to grab
I
a
have
clamp
too.
so that we'll have your aluminum. But what we want is in between the blocks. So what you will see if you are doing too much amperage, letting too much, is it will fall away.
Yeah,
It will just plain make a hole, and you don't get that experience if you have it laying on a piece of steel.
Oh, I see.
So you don't learn.
Well, how do you know I'm going to do that?
Well, you may not.
Just
You may
teasing.
not, but I did when I first started.
Probably will. Am I going to use the pedal this time?
Yeah, we're gonna, let me get you set back up with the pedal. And we also have to change your tungsten too.
Yeah.
We haven't done that.
Are you
but
going to do a different kind of tungsten, or are you going to regrind this one?
I'm gonna use a different kind, and I'm going to give it a little bit more of a flat on the end. And we're gonna use a different collet also because it's smaller. Now, something we're gonna do here, we're gonna set AC TIG, where that one's for the foot switch, the pulses. I need to change. Let me see, that's okay. AC Hertz is okay. AC balance. I don't remember if a small balance holds the TIG up better or a large one. One cleans better and one, and I don't know on this machine because they just give me percentage numbers. And let's see, I can go from 20 to 60. So what's right in the middle of 20 to 60? 40. So let's just put it at 40. Or do we go all the way and find out which is making a difference for us?
Did you have that tungsten in
Yeah,
there?
it's at 40. We'll try it at 40, and then
What about the collet? Did you have that collet too?
you need a different collet there. You need the
that one right
332nd collet,
Is
the
that
medium-sized one.
no? Okay.
Oh, wait, no, this is the 3.
Oh yeah. Seemed like it was not going to go.
Yeah, that's an interesting thing too. Those are actually written in fractional sizes,
Yeah, yeah.
but the manual that came with it mentions them in metrics.
The decimal metric, yeah.
Oops. I can use my hands this time.
So first thing, you're just going to want to, again, just make beads. Just make a little puddle.
Okay.
And just go across the aluminum without any filler. I haven't even brought you over filler yet. Actually, you're a little long sticking out.
Am I?
Yeah.
Okay. Did I even move it? There, that one then. Oh, so you got that little flat tip on there, I see.
Yeah, there's a little bit of a flat, and it will ball out somewhat after it works for a while.
All right.
And it will definitely sound different.
Oh, yeah, okay. So we're ready to do
And we're
something
running
here.
on 120 hertz for the frequency on
And you want me to
this.
start in the middle section?
Yeah, yeah. You can start at the edge near the block, but yeah, you want to be off of the block. I don't think you're making a puddle.
Really?
No, you were just floating along the oxide. You didn't.
I
make
was
a
trying to
puddle.
not make that dip
Yeah,
thing.
yeah, no, you
Okay.
didn't make a puddle at
Should I
all.
go over that same place?
Yeah, you can go over that. Let me. I can watch here since we don't have the
All right.
filler rod anyway. Yeah, go ahead.
Okay, so wait a little longer.
I think you need more amperage. Give it more amperage. There, you have a puddle. Now you're jumping ahead of the puddle. Did you see the puddle?
Yeah, I see it now.
Go a little slower. Yeah. Keep that puddle moving. That's good. You see what you're trying to do with that puddle. You're getting close to where you'll fall through, though. That's pretty good. You might back off your amperage a little. Yeah, cool. There you go. Yeah, Before that, you were just running over the oxide, but yeah, that was
Yeah.
actual melting. And you see where it almost fell away at the
Yeah,
end?
yeah, it was starting to dip down, wasn't it?
Yeah, now, again, you pulled your torch away right away.
Oh, I did.
Even more important on aluminum,
Really?
but you don't see it, but it's more important because the oxides make it harder to re-weld next time.
Oh, huh. Now, would you have to, you just brush that out, or would you have to grind that to, if you're gonna make a pass over the top of one, right there? And you always use stainless steel
Use
brushes with
stainless steel
aluminum, right?
brush,
So what do
yeah.
you want me to do next? Another one of these, or?
Yeah, just run a few more, try to keep it straighter. I'll
Okay.
give you another piece, and we got four pieces, so we'll just burn up two of them. We'll just try to make a bead as you go and not fall through. For reference, you're at 76 amps, 75. I didn't adjust it at all. It just automatically, it came up with 90 amps
I don't know
on
what
your
I did
starting
there.
on
Did I
the high
touch-
end, which is plenty for what
See,
you're
I was
doing.
starting to dip there,
Yeah, just
and then I
about
pulled
fell
it away again. Okay, we'll try.
You can see where what I was saying. You don't get to practice if it's down on the table. You don't
Yeah,
get
yeah,
the aluminum
I see what you're
practice
saying.
of
Oh yeah, I can feel, it's actually melted
yeah.
through.
Don't
Yeah.
touch it and burn up the gloves.
Yeah, oh yeah, you're right, sorry about that. Okay, here we go again.
Yep. Yeah, you're getting close with the tungsten. You're almost dipping. You're doing pretty good there. You did pretty good there.
It wasn't too bad. I did
No.
melt it, I could see it melting. Huh. Okay, don't touch it. So, well, yeah, I was gonna drop through there for a second. It looked like it was pretty close.
Yep.
You gonna show the other side or something, or?
Yeah. Those were both too hot out there, but this was pretty good.
That was a little
That
better.
last one was pretty good.
Ah. And then what was I running for the amperage on that one?
I didn't really see it on the first one, and it wasn't so much the amperage, it's the fact of how long you were staying there.
Oh, okay.
You-
I moved a
there's
little quicker.
combination of things that
Once
make
I got
up
it
the
melting,
heating.
I moved it a little quicker this
Yeah.
last time.
Yeah,
Okay.
yeah, you're seeing where the bead is. Let's go ahead and throw another one up here.
Okay.
Let you run some on it. We'll just set that aside. Throw up our shortest one. And I'll let you do that. Let Bert film it. I'm going to run over here and get some rod. And also the rod, you
Nope.
take.
Now, can you still have metal go on, even if it's aluminum, onto this?
Oh
tungsten?
yeah, even more so.
Oh, even more so?
More obvious.
Oh, wow.
Well, yeah, you'll know it when you hit it with the aluminum.
Yeah, okay.
And I'll get some filler metal, but you go ahead and run some beads on
Okay.
there, get a little more practice.
Okay, we'll try this again. Whoop. Kind of slipped. That wasn't too terrible. So, I guess he wants me to do another one, so here I go. Let me move this block out of the way a little bit. See, I'm kind of angling off pretty good. I can make good arcs, I guess. Maybe if I learn how to do this, I'll be good at arcing. Okay, let's try one more. Let's try a straight one. I got this edge to watch. Oops, sorry, I pulled away quick. I got too close to the edge and the edge started melting down. See that, how that whole edge was starting to go away?
Yeah, you got less aluminum to dissipate heat.
Yeah.
It's tricky.
Okay, I got a little more I can do here. Try over here. One more time.
Just for knowledge, you should stay in one place and just put a hole through it on purpose, just to see what happens.
I don't know what happened. It didn't want to blow through too much. Let me try this one more time.
Well, I mean, you're through it. It just didn't.
It didn't
Yeah,
like.
it didn't sag out all at once, which kind of surprised me. But yeah, okay.
Let me just start an arc right here.
Yeah, it's dancing all over now.
A little bit, yeah.
We'll clean up your tungsten before we let you start doing the filler. It'll be nicer for you. Go ahead and go ahead and melt through. I'm just
I
saying.
was trying to, and it didn't seem to want to.
Oh,
Let me try it again.
okay.
But
The metal's gone, but it didn't sag away.
yeah,
Maybe the newer inverter welder is just easier on it, because when I learned, which was with the real old style,
Oh, yeah.
it was just right away. You'd
Really?
get a melt and poof.
wow.
And it could be the arc balance at 40% might, yeah, make other things easier
yeah.
too. Okay, we're going to move on to, and I cleaned up your rods here.
Are we going to take this tungsten out?
Well, I'm going to yeah, we'll take that out.
Okay.
I'll just grind another one, so
Okay.
we can just swap it out. I'll just grind another one for you. And we will, yeah, put a piece on here. We'll put this one back on here and let you put some filler in it. I kind of wanted to do something really tricky with those two, since we're making good progress on learning.
Yeah.
I was going to actually have you weld them together,
Ah, that's neat.
which, you don't necessarily do as a first time out, but hey, why not?
Why
We're
not?
here.
Sure.
But Bob has experience welding. He's welded with stick, he's welded with torch a little bit, he's done other welding. But this is really his first TIG welding. So
Yep.
it is, it's a reasonable expectation of what you'd have as somebody trying this for the first time out. And I think that after you get past these basics that we're showing you, watch some of the other guys on YouTube. There's some really, really good PAC or PAF is the guy that's, and I forget what it stands for anyway, and he's another one I've watched quite a bit. Welding Tips and Tricks is an easy one to remember. That was the earliest one I knew of that really was showing some good stuff on YouTube. I'm going to give you back to what you had for amperage before I cranked you up trying to make it burn through easy.
Oh,
But
okay.
we'll give you a more reasonable number again.
So I'm going to do some filler now.
Yep, grab and
All right. I can see I'm gonna need a lot of practice at this.
Yeah, you needed to get your filler in there sooner.
Okay, here we go.
You're filling it and it's cratering behind. You need
Yeah.
to, yeah.
Okay, let's try
And
this.
you're wavering forward and back a little bit. You need
Oh.
to establish at one point a little more.
What if I'm trying to put too much filler metal in there, or too hot or something? Okay, I'm not getting the hang of this right
You
away.
want me, let me turn this down so you can have more pedal adjustment.
Okay,
So now your maximum will be less, but you'll have more adjustment on your pedal. Your pedal's not letting you adjust. Oh, there it is. Now you're getting adjustment on your pedal.
yeah, I'm not getting this quite good yet. I don't know what the,
It's harder.
let's try here.
You need it to be less amperage.
No, I'm not quite knowing what.
Okay, let's stop for a second just for fun. Let me see. I think we're probably, yeah, we're definitely contaminated. But, yeah. Let me grind another tungsten,
Okay,
and we'll swap that out. I'm just going to try a little bit myself, just for kicks there.
okay.
No. I think it's been over a year, actually. That was terrible. I was using the frozen puddle to hold the stick. Oops. I think I hit the electrode there, didn't I? Yeah.
Well,
Well, the machine will do it.
you're getting the metal on there. I guess I was getting it there somewhat, but it was melting in too far,
Yeah, you're letting the puddle, letting it spread out too much.
holding it there too long.
And at first, yeah, I wasn't doing it right at all, and I definitely need my reading glasses to even try that. It's been at least a year since I've done any aluminum, and usually this kid is doing thicker aluminum. Thin aluminum is harder than thick aluminum, and that's part of why when you first start learning, they give you thin aluminum.
Yeah, I
Once you
see.
get good at thin aluminum, you can do the other stuff. And that was when I was doing the TIG, it was normally heavy aluminum pieces, so it was kind of a cheat. I did get, at Red Dog Mine though, I was doing some really thin, fine aluminum, and my eyes were younger. And actually I was doing pretty good then, with a little aluminum cooler for a hydraulic system. It was welding the cooler tubes, little fine cooler tubes actually. So, yeah. But that was 30, that would have been 94, 95?
I'm actually kind of, how would you say it, deciding that I'm not going to go to work anymore today. This is fun to be with the guys and, stimulate our mind about doing something, learning something new. for somebody that hasn't done
But
it
yeah,
before.
you want to establish your rod into your puddle. And what I did there, I had the rod not going into the puddle. And I should have melted and had a little bit more of a puddle before I brought the filler into it. And here, we'll give you a whole new piece to work with.
Let me just turn this around here. Just so I can clamp that back here.
It would be easier over something sucking the heat away a little bit, but
Oh, I see.
that's not what we want to do. We're trying to learn. Later on, you can do all kinds of things to make the welding easier for you. But this is on purpose. We're putting this out in space with relatively thin aluminum. This is 1/8 inch thick. And it makes it harder. It does.
Well, we'll try this again here. For me, I mean. Get this cable over here. How much did you? How much pedal were you giving it when you were welding?
I
John?
don't know, Bob.
You don't know? Okay.
I don't know.
I kind of did like. Let's see. I didn't start to melt yet. Stop there. Well, I was getting a bead anyway, even though it's kind of
Yeah.
drawing somebody's
Perfect, but
name.
you got a little bit of a weld piece. Here, let's just.
I can do right here. Is that okay?
Yeah, that's okay.
Okay. So something I was doing where I started okay a little bit, and then I don't know what that was. Boy, I had to really shove that rod in there quick. Did you do that, John? You were really shoving it in there?
Yeah,
Am I getting too hot or what? Let's try.
Yeah, you want to back up more to make room than raising way up.
What's that?
You're raising up, trying to keep away from the rod. You want to do more of a backup.
Oh, really? Okay.
And I know it's bad.
I think it's going to take a time for me to,
Tungsten's bad, yeah.
once it gets bad, you're not going to get good welding, is that right?
No, no, you can still get some practice. I mean, you can push it beyond where you're supposed to, but it doesn't come out good. I'm just curious about trying something else here too. We could even, let's just try.
Oh. Did you want anything? Oh,
I don't have a clamping that's gonna do it correctly. I was gonna say just
oh,
melting.
right on the edge?
Just melting the two, let me see here. Give me the, wait. My hand, let's put the clamp on them. Let's clamp the two together. And
No,
set-
what's the dangers associated with this arc and,
On the high frequency, you get the high frequency, you get a really good electric fence shock. I mean, it really, I've got it before, it really
Really?
doesn't feel good
oh, wow.
when it's establishing the high frequency.
Oh.
That's when it really gets you. Let's just do this, and I'm gonna put the ground right on it. And just run along the top, and just try and run a bead without any filler. Just
Yeah,
welding the two
fuse
together
it.
with no filler.
Fuse. Okay.
You're getting too close.
I wonder if that thing's just bad. Okay,
We can read.
one more time.
Need more heat.
Well, it's funny, it's just not melting it.
Yeah, your tungsten's terrible.
That's the reason for all that? I'm giving you a lot of work, huh?
I'm gonna fix another one.
Well, I am trying to do this, and on the aluminum, I'm having a little bit of a difficulty. So,
Using
Something-
pointed tungstens is a little bit, for aluminum, is a little bit new to me too. Like I said, I'd always used the bald, which I'm not showing you because it's not the standard procedure anymore.
oops. Those little collets are kind of thin, aren't they?
In fact is, when I welded a year or 2 years ago, whatever it was, I would have, I think I was starting to try the tapered, but I may have still just used a small bald tungsten, which gives you a bigger puddle. You cannot have as small of a puddle. One thing you were doing, Bob, is you were making an arc here, and then you're trying to make it over here, and just stay in the middle
Yeah.
and let it melt both
Yeah.
of them right in the middle,
Yeah.
and adjust your amperage,
Okay.
and then move on once the two melt together.
Yeah.
Get up higher on your arc. Give it more amperage. More amperage. Stay in one spot. It's not melted together yet.
I got it all the way up.
We give you. I give you more amperage available. Okay. There you go. He just needed more heat.
So we needed a lot more heat, huh?
Yeah.
It doesn't look too bad.
No, that's good.
Yeah.
You just
okay.
needed more heat. I had you turned down because we were
Yeah.
sinking through before. Mm-hmm. Then everybody just play TIG welder.
Here, John, my back's
fun.
getting sore. I got to get
Oh.
up. Hope you don't mind.
No, that's okay. That's okay.
Oh,
We just wanted to have a little bit of instruction.
yeah. That
From-
actually looks pretty good. Look at that. It's nice to do something and look at it as good product and good appearance too.
Yeah, and see, this, to me, relatively even on the top. That looks a lot nicer to me than big old ripples of dimes that they talk about. To me, because it's stronger. The smoother your weld is, the stronger it is. You don't have those stress points in between. And it's no stronger than the smallest part of it. It's like a chain. I mean, why do we want all
Yeah.
this big?
Yeah.
Well,
Yeah. Well,
that's
thanks
what
for
they
that.
consider pretty.
Thanks for that experience.
So.
Seems like it's nice in that you can throw that thing up on a table and get started and
Yeah,
go pretty
and-
quick, huh?
I like the fact that it's AC. It really starts nice.
Yep.
The high frequency, it starts really nice. I like that. Okay, so that's it. Welder works, welds. It has the pulse function too, but honestly, since we're working on learning while it's there, I'm sure it works great. Don't worry about it till you learn to TIG weld a little bit. Get into TIG welding first. I mean, get into doing it just basic. And then what the pulsing will do is it will give you a automatic change in amperage so that it will time you to amperage comes up, makes a puddle, you back off a little bit, you put your rod in. But learn to do it manually first. Learn to do it manually. Don't rest on that. It can make prettier welds that way after you learn to weld.